go out, and then Jayun remains the same. So recovered well. So first thing that you need to do, by the way, anybody has any questions? No. Okay. The first thing that you need to know is to show, yeah, in your case, I want you to use your root username and password. You didn't yet know how to create users, right? That'll be learned in another class. We have distributed database classes, but here is an introduction. So rather than working on any security issues on databases, we will look at only the concepts of databases with some skill sets. So we'll do this here and show databases. So right now we need to know what databases are available here. Right now we didn't have any application databases. These are all the databases given by MySQL. For example, user accounts, privileges, they are all stored here in MySQL. Okay, this is so-called catalog database. Your application database, some knowledge about your application database should be stored in another database, which is MySQL. There are many others also here. Some of the schema databases there, systematic issues there. So we don't touch any of this, but we need to create a new database. So create, like here on this slide, create database, and registrars, yes, let's follow that. Registrar. Then it is stored, saved. So we'll see the list of databases. Now we have here registrar, right? So we're going to use that specific database. So using the command use registrar. By the way, in most database systems, in the command line, then you need to, at the end of each command line, you have to put a semicolon. So semicolon is the delimiter indicating the completion of that statements. Reason why we have this semicolon is because the SQL statement, for example, it may be very long. I'll show you a little later. Then you need to make a new lines and another lines to show better structure of that statements. Then finally at the end that you can put semicolon, then that is the end of entire, but still one SQL statements. Okay, one SQL statements in multiple lines. Even if you hit return or enter button, it doesn't execute. For example, if I don't put any semicolon, or in this case it works, but MySQL, okay, I mean SQL statements. So right now we are under registrar database. Show any tables there. Of course, there is no tables. In this case, for example, show data tables. If I don't put the semicolon, it gives me new lines until I say, hey, this is the end of my command line. Then it'll show there's no tables. So we need to create table. Create table student and CWID integer. Type of CWID is integer, and name is text. Major is also text. For a while, we don't put any, for example, CWID is primary key, because this is an introductory level of database. I want you to understand a little bit of database concept and a little bit of hands-on. All other details, all other security sensitive issues needs to be learned in another class. So we look at only that simple ones, and then again create another table. Create table, that's a reserved word, and then we have a course. Course says title. Type of title is text, and comma, that is the delimiter between attribute name and type sets. We have a title and CRN, that is integer, and credit, that's integer, and instructor, text, close, and semicolon. Then another create table, and then if I hit enter, then there is a new line. Create table, enroll. Enroll has CWID, which is integer, CRN, that also integer, and then semicolon. So we have, for example, if I want to see the tables already defined, then I can see that, right? We have 3 tables defined. Now it is time to insert populate data. The language to populate data start with the insert into, followed by table name, student, and then if you want to specify the list of attribute, we can do that. Name and major and values, and then we can do 1, 2, 3 Adam, cyber, semicolon, then it is inserted, right? In another simple way, if we entered, well, we can do in another way, CWID, major, name, values. The difference here is that this is the attribute names as in the same order as defined, but I could change it, the order difference. If you want to change different order, then you need to specify here. So the first one is CWID, the second one is not the name but major, and the third one is name. You should explicitly specify here the order of the list of that attribute, and then in the value you have to also correspondingly in that order. So the second one is 1, 2, 5. Major is a cyber, and name is Peter. This works in this case, right? Or you can, if you want to follow the order as it is defined, the order of the attribute as it is defined, then you can simply say insert into student and values, and then 135, Chris, and then major CS, and then semicolon, then it is inserted. So if we want to see those the insertions, the populations of that table, then you need to do select. If you want to see all attribute, select star, and then from what tables, student. There's no where close, then you can, what that means is that I want to see all the data populated in that specific table, students, then you can see that. So that is this. In the, so we have CWID name and majors. They're all that I entered by these three statements, right? In the same way, I could do, let me see if I can, I cannot copy it. I think I can copy it, right, to save time. So that I can do, for the course, similarly I can make here. I made that, and another course taught by John, right? So select star from course, then I have two courses, coding and database. CRN number is 111, as we do here, 111. Database 525, credit 3 credit each, instructor John. That's how I inserted it, right? Similarly, we could do I'm going to, what I'm going to do, copy one here, values, so that in role we have CRN number, no, CWID and CRN number. If you want to populate more than one record at the same time, then you could do in this way. I have here 1, 2, 3, and 525. So I'm going to do here the same student 1, 2, 3, and 525. You can do it like this. Or I have another students, so 1, 2, 3, another students 1 to 5, 1 to 5 students, takes, for example, here CRN 111, 3 records at one command, and at the end semicolon and hit enter, then it says 3 records are entered, right? So if you want to see that, then select start from enroll, then 3 items there. Okay. Let's see what. So we need to have more than those, right? As you can see here, we have only, I want you to have 2, 3, 4, 5 records for enroll. And right now, our course we have 2. I want you to have 1 more. And then students, we have only 3 students. I want you to have 1 more students. Please do that right now. If you have been following my lecture so far, please do the same way that you can see here, so that we can practice it better. Okay? Let's see if I can. So you can see. Are you guys doing okay? Bora, how about you?
Yes.
Following? Are you okay? Following? I know it is not slow, right? I did a quick, so how about Angelica?
Yes, I'm good.
Oh, good. Jace?
I'm doing good. I'm just putting them all in right now.
All right. Anthony?
Yeah, good.
Oh, you guys are all good. Great. Do you want me to move or wait?
I'm good to move on. Yeah, me too.
Yeah, I'm going to, as you guys do, I'm going to add a little bit more silently so that you can do that too also. Insert into course values. I think defense 553. Usman. Okay. Let's see. Enroll 1 to 5, 525. But I put here one. Okay. So what I'll do, values 1 to 5, 525, 135, 525, 550, and students. Values 133. Okay. My database, almost all of this. I think one more records for enroll, I believe. So I have 1 to 5, takes 111, which is one additional to this 5 records there. And I believe all others the same. Start from students. Okay. All right. So we look at the SFW clause. What it means is that select from where clause. Select from where. To answer the questions, I have 2 questions here in SFW clause. So list the courses taught by John. So how do you know who courses? List courses taught by John. So we need to find out which table that we are going to use. So this is John, probably instructor. So instructor here taught which course. So John teaches 2 courses here, right? Apparently. So how can you get that? How can you express that in SQL statements? So course that I probably title only. Select the title from table name, course, where, that is the condition, John, that is instructor, so we need to say instructor, attribute instructor is the same as the name John. So here is what I'm going to do. Select title, there's S close. I want to make it 3 different lines. Okay, that's okay. So select the title, S close, and from close, from followed by table name, select followed by attribute name, from followed by table name, where followed by the predicates, which is attribute name, operator, and value, or another operand. So operand, operator, operand. The left side here is attribute, right hand side here value itself. Okay, so if we issue this kind of SQL statements, then there's a SQL processor. Processor comes here to convert that to real code, real, actually C code in most cases. But let's assume that it is converted to Python. Then this guy scan through this table, open up the first record from this course table, open up and read first of all where close, because it says instructor. This predicate condition is specified over instructor attribute. Come here, say it should say John. Okay, if this where close is satisfied, then in the select close there's a list of attributes. It says title, so hey, only title coding, and put that on the basket, and then go to next record and compare the instructor. If satisfied, add this. If not satisfied, move on, and until it reaches the end of this table. That's how it works. That is what that SQL processor is performed. So by hit the return key, then we will get the result of that. So these 2 courses are taught by John, right? Next one is list the students who study the cyber major. Then students, where is the student? Students is here. And then there is a major, cyber and computer science. So we don't need to consider other tables, about only one table here, right? So similarly, select student, then hopefully this guy may ask name. If some other cases a CWID as well, then we can say CWID. And if we want to say, hey, I do not want to put the CWID, that attribute name as is, simply we can say ID. And then from student table. If we have more than one table, then we have a list of those tables with the comma as a delimiter. And then where there is a condition, major equals cyber. If we put their cyber with the quote and unquote, then this guy is simply the value itself, which means cyber is not evaluated. Unless otherwise, then there are some words reserved this where that is known by MySQL, from that is known, student that is not known. In this case, students may be in the database. So look at the database. If there is a student, that is already defined, right, by the definition of these tables or database. Same thing here, major. That is not string, that is not literally major, but it is a variable or attributes. So that is already here, major. So this guy, major, student, name, CWID, they all needs to be evaluated, which means verify if it is known. Okay. And finally, we'll put a semicolon, hit enter. Then Adam and Peter. Adam and Peter is in the cyber major, and ID 123126. Rather than we spell out exact same attribute defined in this database, then I can change it to well-known the word ID, right? Partly that is a kind of service, partly for security reasons. If we put here CWID, then it may be known by someone who wants to attack your database. So you can disguise the attribute name itself. All right? The next one is, then we want to join the tables. When we solve the query, one table may not be sufficient. So more than one table needed. Then those tables needs to be put on that from clause. For example, in this example, list the students with the course title. Student with the course title. Student, I'll assume that is a student name. Then that comes from student table. Course title. Title is not available in this student table, but title ID itself may be available here in role, but title name itself here in the course. If we see course and student, go back here. Course and student are not directly related. Course and student are related through enroll. Until I enroll a specific course has nothing to do with me, right? Course has something to do with me if I enroll in that course. Therefore, course information and the credit that I earn can finally be shown in my transcript. Therefore, enroll is the relationship between student and course. From this logical design, outcome of, this is a conceptual design, right? Outcome of this conceptual design is ER diagram. This ER diagram, box and diamond, may not be well known, may not be known by database management system. So we need to convert this to database schema, which is yet another design. We call this logical design. So we have a logical design here, right? That finally we have implemented in a database. So this title is here. Student name is in another table, student and course. If we look at attribute here and attribute there, there is no common attribute at all, right? What that means is that those two tables are independent unless we include the table enroll. Recalling that ER diagrams, enroll is a diamond, right? So this guy is the relationship between course and student. So if we look all of these three tables, then they are related. They are related based upon attributes. If attributes are shared, if an attribute is shared, then they are related. For example, student table and enroll. Student CWID is shared with the enroll here, CWID. So CWID is shared in these two tables, enroll and students. Clearly we see Adam, whose CWID is 123, is taking CRN 111 and 525. 123 takes 111 and 525. So these two tables are related. If you look at course and enroll, then course has CRN number, which is shared with enroll. See here CRN, and there is a CRN. So course, by looking at this CRN number, we know what course title is. We know who teaches that course, right? If we combine all that, so because enroll and students are related, and enroll and course again related, therefore student and course are related. They are related through this enroll. See here, list student name and title. Title in another table, like student name. They are not directly related, but if we include enroll, then they can be related indirectly. So looking at this to here, that are taken by the students. So we know, we can say, for example, Adam, give me the title of the course that Adam takes. Then we see here Adam name, Adam CWID is 123, and come back here enroll. Then we'll look at the CWID of 123. Then we found two records, 123, and therefore CRN numbers 111 and 525. And when we move to the course table, 111 title for 111 is coding, title for 525 is databases. Hey, this is the answer, right? We traverse from a table to another table, then we can identify which records are the records that we want to find, right? We can do that manually. So how can we describe that in the SQL language? Then we can do here select, and then student means student name. So we can say name and title, right? and then from student course, but they are not directly related. Therefore, I want to put here. The order is not really the matter here, but for me to see in better way, I can say student enroll and then course. You don't need to do that. If you do not want to, then you can say simply student and course through enroll. And where so those guys needs to be taken, right? So let's say if you see here, there's no specific the condition that we looked at in another case, like here. Then we have John and Major Cyber, but not that specific description here. Looking at who takes what course. If somebody stops here, guess what? I have so many. When I do this manually, then I know only 2 coding and databases. How come I have these many? How many? 72 rows. How come I have 72 rows? And why this happens if I do this? So in database, the SQL processor, by having this only, this guy gives us all possible combinations among student, course, and enroll. And if I put here where clause, then from this, based upon the where clause, the condition, we select something that is applicable. Okay? Up to this point, it gives me all possible combinations among those 3 tables. Gives me 72. I have 3 courses here, and then remember we have 6 enrolls and 4 students. 6 times 4, then 24. 24 times 3, then that's 72, right? So 72, number 72 comes from the production of all of those. If you want to get real clear the answer to this query, then you have to specify, as we did manually, we do not match arbitrarily record by record with the others, but we have to see, as we did, this CWID should be the same as the CWID here, right? Do you see that? We see only CWID. 1, 2, 3 should be matched with the 1, 2, 3. Therefore, Adam can takes only 111 and 525. If you see here 1, 2, 3, Adam takes coding database and also defense. Adam takes defense also 550. All possible combinations. All right. So I want to do where clause. That CWID should be the same as CWID. Whoops. If I do this, let's try to do this. So CRN should be the same as CRN. If you see here, although I see this first CWID, hopefully for the student CWID, second CWID is CWID in enroll. first CRN is the enroll CRN, and second CRN is course CRN. Assume that is my too optimistic approach, which it may not. See what happens. Okay, we need to see how it goes. It gives me, if this query processor works well, then it gives me an error, right? It gives me an error. What did it say? Column CWID in where clause is ambiguous. Ambiguity. Ambiguity comes from because we do not know which sub CWID of what. So we have to clearly, explicitly say what it is, right? So rather than doing that, we should say CWID. This CWID is, first of all, student CWID. And second one is enroll dot CWID. Similarly, CRN is enroll dot CRN. And then second CRN, maybe the course CRN. Course dot CRN. If you do this, then it gives me, hey, Adam takes database, Adam takes coding, Peter takes defense, Peter takes coding, and Chris takes database, right? Look at this. This is there any other way that we can make it a little bit in better way? If there is ambiguities, then you can say, hey, I have an alias. So S is alias for student. C is alias for course. E is alias for enroll. Therefore, rather than spelling out student, we can say S dot. Rather than enroll, we can say E dot. Rather than course, we could say C dot, which is better, right? Better description, same performance. That's what I explained this. So why join condition is needed? That way we can filter something unrealistic records. Therefore, we can gain something realistic. Okay. So next one is that's what we had here, right? This guy is 5, but we have also we have 5, right? This Peter has defense. A little different way of that. That's fine. Okay. Who takes what course? That's what we already had, right? More than this. In this case, student and enroll. Therefore, we have only CRN. So next one is list who teaches what students. Okay, let's do this. Who teaches what students? Select, then who, that is instructor. What student, that's a student name. Same thing here, if you want to spell it out more explicitly, then instructor comes from the course, and then name comes from student, therefore student name. And then from, we have student, S, enroll E, and course, C, where clause, then student CWID should be the same as enroll.cwid and enroll.crn equals course.crn. And then finally semicolon, then you will get who teaches what. John teaches Adams. John teaches Adams, but in this case, probably John teaches Adam through 2 courses, right? John, yeah. If we want to make it more clearly, then you can say title also. So who teaches to what students through what course? So C dot title. More clearly, say John teaches Adam the database. John teaches Adam coding, and so on and so forth. Aggregation is also possible. For example, in this case, who takes how many credits? Who takes how many credits? You have a credit here. Who takes? Who? There's a student. Therefore, that is in student table. Credit is in the course here, but we want to add them. So initially we simply say, by changing this a little bit, then we can say here students takes S the name takes a C title with C dot credit. Okay, then we can say Adam takes database, which is 3 credits, coding 3 credits. But if there is a different number of credits, then we will see the different here. But at Mercy, for example, Mercy University has only almost all, particularly cybersecurity course, all uniformly 4 credit hours, right? Yeah, some undergrads 4 credit hours. The coding courses 4 credits, even in cybersecurity. But anyway, for graduate level, all 3. So I want to, rather than showing this, I want to see here, Adam totals 6 credits. Peter, we have 2 of those. Peter also 6 credit hours. And then Chris, 3 credits. How can we do that? Then we need to think about that. If we want to do this, then we need to group by student name, right? So we first group by student name, and then we have sum of credit, right? Summations. Generally, we have to group by name. So by Adam, we have 6. For another name, Peter, we have 6. For another name, Chris, we have 3 only. So we need to make that way, which is called aggregates. In order to aggregate, then you need to say here by s.name. We need to group them based upon name, student name. And then we need to do credit needs to be summation. Sum.credits. So S name may appear once. If there are 2 records together, then we need to combine these two records into one, right, by adding credits. This title, however, if we leave this title here, then this SQL statements, the processor gives us an error because we cannot, this is not aggregation at all, right? How can we aggregate title? We can aggregate by adding the credit, which is integer, by adding, which is a sum. This is a function, aggregate function, summation. We can aggregate these two, but this title cannot be aggregated, right? So this should be removed. But let's see, if we have this, then it gives us an error, right? It should give an error. But if we remove that title, then we will be okay. That makes sense, right? Oops, what happens? What did it say? Wasn't for the right syntax to use in the oh, rather than by only, we need to say group by. So group by, not just by. So we add them. Okay. Also, if we want to list this order by name, right now we have Adam, Peter, Chris. We can say order by s dot name. Then nicely Adam, Chris, and Peter. I added one more clause here. So we have order by, group by, and order by. Left to right join. So let's say the students and enroll, who takes what CRN, okay? So select all from student and enroll, where I would say student S for alias, E as well, and then s.cwid equals e.cwid semicolon. Then we know Adam takes 2, Peter takes 2, Peter takes 3 courses, and then Chris takes wait a minute. Peter takes 3. One to five. Why Peter takes 6 only? Peter takes Peter. Oh, 535. 535 is not appeared. Right, that is the reason. 535 is not. Select the start from course Yeah, 535 is dangling. It's not available here. I think it's typo. Yeah. So for example, select star from enroll, then we have 525, 535. It should be 525. If we want to change it, then update enroll, set CRN equals 525 rather than 525, where CWID is where CRN is 535. If 535, then change to 525. I'm not sure it works. Hopefully. Yeah, I think it should work. So we have 525. If we do that, then go back to their aggregate function here. Yeah, then Peter has 9 and Adam 6, Chris 3. What do I want to do here? Okay, here, so that we have Peter takes 3 courses, Chris takes 1 course, Adam takes 2 courses, right? If we see here David, let's say student, select from student. Apparently, manually we see here David is not taking any course in this semester. That happens, right? Can we show that here? This SQL statement shows us only something available. But see, the university administrator, yeah, although they have the interest in the students continue to be in Mercy University, but they are also interested in somebody not anymore or not available at this time. Can we show that also? How can we make it? Not only something that they are connected, but even if they are not connected, can we show that? That is left to join or right to join. That's what we want to do. Okay? So similar to this, but change a little bit. Select a star from student S up to this point the same, right? But here, literally we say left join with the enroll E on, this is the same. Only this is that highlighted here is switched with this. And then we do here s.cwid equals c.cwid, semicolon. Oops. E.cwid, not C. Enrollment. Then we can see not only something realistically available, but something not available. Then it shows me the null value there. This kind of information is also important in many cases, right? Not only something exists, but also something not available. Okay? This is very, very useful information in many cases, right? And also we can make, using this, aggregation as well. So name, student name, and as the name, and then sum of course.credit from student enroll and we do this first, student enroll on this. That is also left join with course C and on E dot CRN equals C dot CRN and group by S dot name. Very similar to the previous ones that we looked at. Aggregate like this, but this shows only something available. I want to see, for example, David, null. Adam has 6 credits, Chris 3 credits, Peter has 9 credits, I was enrolled, but David, none, 0. Right? That's what I want to see. That's what I want to report to the president of the Mercy University, right? For example. Hit enter, then it gives me that, right? If you want to do also order by as the name, you can do that. Or, for example, Adam, Chris in that order. But if you want to show to them, for example, the order of credit numbers. So C dot credit. See that, let's say here, if we wanted to change this rather than sum with the parenthesis as another alias, as we done in other case, so that we can see here credits. Then we can do I'm not sure. Let's do this first. Order. Therefore, we have credits here. Rather than showing this, we say credits. I want to test if I want to in another order. If I do here order by credit, I suspect if this is recognized by these credits. If it recognized, then it's a little more intelligent. Other than that, that's fine. Let's try. Oh, yeah, it recognized our alias. So credits. So order by the credits, who never. So all the null values appears first, and then that's an ascending order. But if we do order by descending order, Order by credit. Descending. There's a syntax issue. If it doesn't work, then I'll look it up, see what it is. Oh, it works. So if we put here DESC for descending, then highest value appears first. So this makes our president happy. This makes our department chair informed, right? Who not involved, therefore department chair needs to take care of this guy. Things like that. So this is a difference between these two, right? So one that you can see something available. The other ones, both available and unavailable. I believe this is it for today's lecture. Any questions?